What's up, guys? Let's take a look at another CodeWars exercise. This one's called triangle type. It gives you the sides of a triangle, and we need to find, is it right, acute, obtuse, or is it not a triangle at all if they give us some bad combo. Now, there are probably a lot of ways to do that. The one that sticks in my mind is the Pythagorean theorem. We're going to take the squares of those sides and compare them. So I'm going to use that as my base. When you start, they give us a little comment just to remind you, and that is good because the 1, 2, 3 thing would be hard to remember. So let's make little baby functions for each one that's going to tell you, is it right, yes or no? Is it acute, yes or no? And then we'll call those preparing each output. So I'm going to say right, because that's the classic one, easy to remember. A, B, C, and we're going to say A squared plus B squared equals C squared. If that's true, it's got to be a right triangle. We don't have to do sine or cosine to find the angle. We just know that this ratio holds. So how about the acute? Well, now we have a reminder that these A, B, and C are given to us in any order. So we're going to have to find the big boy and put it in the C spot before it gets to these functions. When I say right, A squared, B squared equals C squared, that only makes sense if C is the big one, the hypotenuse. So I'm going to have to tell myself, before we send it to these functions, we got to sort them, or at least put the biggest one last. But assuming we do that, the way to tell if it's acute would be if the biggest one is not big enough. So we're going to say the same thing with a greater than over here, because the biggest one is not big enough to qualify as right, or even more to qualify as obtuse. And then I'm not going to make an obtuse because it's just the last one. You can just be the else in our order here, but we do need the bad, the invalid. Is invalid a keyword? No, let's go with invalid, and it'll take the A, B, and C. And what we need to check is the biggest one is not big enough. Like, we have this idea of I think it's called the triangle inequality, where any two have to be bigger than the other one. So we can say A plus B is not enough to cover C. Oh, earlier I said the biggest one's not big enough. This is checking if the biggest one is too big. So now I think that's right, but let's test them. So we're going to make a little expression here to say, okay, we're going to return 0 if invalid something. Well, remember I said we need to sort them, so let's call it try for triangle equals sorted ABC. And so if we put that try through the function and it comes up with a true, then that means whichever particular function we're looking for is the answer. So 0 if invalid, else 1 if acute, else. Now you could make a dictionary, you could do other ways to find the else stuff, but let's say we just got it this way. 2 is right, and I'm putting the star here, which is called unpacking or splat, to say that this triangle, this tuple of 3 things, is peeled open into just 3 separate things with no parentheses to be the parameters. Else 3. And like I said, we don't actually need to check for obtuse, because if it's not the others, then there's only one option left, because we've checked for the bad and the other sides. So I think I might have got it, or I might have had some terrible typos. Nope, we got it. That's great. Let's hit attempt just to be sure, and there you go. What I always like to do on these is to look at the solutions from other people, because it may turn out that I missed something obvious, or that I just did something twice and could have shortened it. Let's see how they go. Alright, this person did the sorted, this person did the sorted, so you can tell that's going to be the first step in a lot of these, in order to make sure that we can compare the littles to the big as a part of most of these. So they're checking if it's bad that 2 of them don't add up to as much as the other one. They're checking the classic Pythagorean theorem, and then they're checking the acute and obtuse in kind of one step, which is nice. This person did pretty much the same thing. Turns out I'm not really that special, and mostly the stuff that I came up with is gonna appear in the others as well. Yep, same thing. Yep, I like the spacing, I like the tabs. I think this one's very readable, but it's the same idea. And there you go. Some of them have a name for this diff, or one of them called T, I don't know what that stands for, to say that, hey, we've got the Pythagorean theorem shifted a little bit to compare, is it bigger, smaller, or equal, and then that is nice. A little intermediate name for that idea instead of just writing them out every time. And it looks like we're going to see mostly the same stuff. This person made a function with a slightly longer name, and they used the def instead of the lambda, but it's the same thing that I did, and they're all pretty readable, except this one. I don't think that one's very readable, even though it is doing the same thing as mine. So keep an eye on whether it looks horrible, and if you end up with some one-line function, that doesn't mean you've succeeded. You might take 4 or 5 lines to do it in a nicer way. There you go.